Hello students, welcome back. In this video, we're going to do chapter 5, which is solving exponential equations. There will be some examples given, and then there will be some try it yourself questions. So more or less, this is a self-directed lesson. Right, let's recap on some important rules. They may be needed in solving exponential equations. These are the rules that's under the chapter on integers. I think most of the time we'll be using these rules here. This one here. And then this one here. Right. But we may also use some other rules. All right. So it's best to recap on some of this if you have forgotten. Right. So what are the concepts that are needed to solve exponential equation? Before that, let's understand what is an exponential equation. It is basically one in which a variable occurs in the exponent. What does it mean? The exponent refers to the power or the index. So for example, if you're given 3 to the power of x equals to 2187, this variable refers to the letter x here, and this letter x appears as the power or the index of base 3. Another word for the power or index, that's the word exponent. So what we need to do here is to find the values of x, such as 3 to the value, which gives you 2187. So another example could be solve the exponential equation to the power of x equals to 1024. So what rules do we need to solve the exponential equation? Basically, we need to know the laws of integers, which we have done so in the earlier slides, and some definitions, which is required to simplify the exponential before we solve it. And what methods do we use? Right, for solving a simple exponential equation, we can just equate the exponents. The exponents meaning the power. So if you have a to the power of x equals to a to the power of n, if the base are the same, then the power would be the same too. But there are certain conditions that you need to apply here. For example, a must be a positive value. Do you know why? Because what happens if a is a negative value? And a mustn't be equals to 1. And what is the reason that a mustn't be equals to 1? So think of what happened if a is equals to 1. Think of what happened if a is a negative value. Do you think you can still apply this method of equating exponent? Then the second method that we'll be using is substitution, right? Where you need to substitute 2 to the power of x to be a certain letters, and then you will obtain the quadratic equations in u, where we solved for u and then finally solve for x. So we will be having examples and also do it yourself for you to apply the concepts learned. Right, we're going to start off with some very basic questions, such as you just need to solve like a to the power of x equals to b, and then there's only one solution of x. So basically what we can do here is just to make this exponential equations having the same base, and then you just compare the power. Right, so let's look at all these questions. Let's look at part A, 3 to the power of 4x is equals to 81. So basically all we need to do is just rewrite 81 as 3 to the power of 4. And you can see that we have both base 3 on the left and the right, and therefore you can equate the exponent, which is the power, which is 4x equals to 4, and therefore x is equals to 1. And you can just substitute x equals to 1 into the original exponential equations, and if you were to substitute x equals to 1, then you'll get 3 to the power of 4, and 3 to the power of 4 is equals to 81, which is the value on the right hand side. So x equals to 1 is a valid answer. So if you look at part B, right, okay, what the bracket here means, it represents the operations for multiplication. So what we are saying, it's 9 times 3 to the power of negative x. And 9, you can write it as 3 to the power of 2. So 3 to the power of 2 times 3 to the power of negative x will gives you 3 to the power of x minus 2 on the right hand side. And then we can apply this rule. It is a very basic rule in the rules of indices. We have the same base, and what do you do with the power? You just add them. So basically, I'm just adding 2 plus bracket negative x, and then since we have the same base 3 on both sides, therefore the exponents must be the same. And from there, we go on to solve for x, where we get x is equals to 2. And you can again substitute x equals to 2 into the original exponential equation, and then verify if the left hand side's value is equals to the value on the right hand side. Let's look at part C. So part C, you will have to apply the fractional index, the rules to convert it from fractional index into radical, to convert the radical form into an index form. So basically, we apply this rule, okay? So we need to write this one here. So if you were to recall how you can remember it, the one outside your radical sign will be at the denominator, the one inside is at the numerator. So that means 2 to the power of x over 3, because the number 3 is outside your radical sign here. So one way to remember it is this will be a denominator because you're out of the radical house. And then the one inside, which is the exponents, which is the power of base 2, that will be the numerator. All right, and that is equals to 2 to the power of 6, because 2 to the power of 6 gives you 64. So now we have the same base, so we can compare the exponent, and you multiply by 3 on both sides, so x is equals to 18. All right, let's look at two other questions. They are slightly harder than the previous one, but it's not that difficult too. All we need to do is, if you look at part D, all right, we just have to express all the numbers as base 2. So 8 is 2 to the power of 3, and then 4 is 2 to the power of 2. And then you have to apply, yes, the rules that are written there. A to the power of n bracket to the power of n is equals to a to the power of mn. Right, so basically what's happening here is that you just take 3 times x to give you 3x, and then 2 times 3x to give you 6x, and 2 times 1 to give you 2. Right, and then we apply another rule that we have learned. Yes, a to the power of m divided by a to the power of n will give you a to the power of m minus n. Right, and we compare the exponents since they are base 2 on both sides. And then you end up with the quadratic equations where you can factorize it to get two answers, x equals to -2 or x equals to -1. Now for part E, right, we have to make it, so far if you were to realize that we are solving exponential equations, it's something on the left equals to something on the right. So what we need to do here for part E is to bring your -64 to the power of 2 minus x to the right hand side. That means we basically add 64 to the power of 2 minus x on both sides. And then we end up getting, yes, and 64 is just 4 to the power of 3, right? And then we apply the rules that we have learned in the chapter of indices. Then we compare the exponent. Right, so basically all these questions, all we need to do is just to make the base the same, and then you compare the exponent. All right, so pretty easy. Right, so these are some of the try it yourself questions that you may attempt. It's not difficult, right? So some hints given to you. For example, this one here, you may have to apply this rule. Okay, and then this one here, you may have to apply again the same rule that what I've written here. All right. Right, so for these questions here, basically you just express it as base 2 throughout, and apply some rules of indices. Make sure that the base are the same on the left and the right, and then you compare the exponent. Right, sometimes you may be given two simultaneous equations with the two unknowns, and then you solve them. Right, so basically all you need to do is just to convert the first equations into into the exponential form. Right, and then since the base is the same, you compare the exponent. And then similarly for the second one, so the concepts are the same, except now that you're having two unknowns, therefore you need to solve them simultaneously. Alright, so you make x the subject here, call it equation 2, substitute equation 2 into equation 1. Find for the values of x. You have to find for the values of y first, and then substitute the values of y into equation 1 to find the values of x. So here it's actually nothing very new, just that you're given two unknowns, therefore you need to generate two equations, right, and then you solve them simultaneously. Okay, so this is another questions that you can try it on the own, right? It's not difficult again. You can actually look at the previous example and then apply the same concepts. Right, so sometimes the questions may not be that basic in the sense that you cannot just, there's no way that you can actually express the number as the same base on the left and also on the right. Right, so in this case here, then you have to use another method. Right, so for example, if you're given like, 2 to the power of 2x plus 3 to the power 3 times 2 to the power x minus 4 equals to 0, you see that there is no way that you can actually, usually for the past few examples, usually what we have is just one term on the left equals to another term on the right. Here you have three terms. Okay, if you see you've got three terms. So if you have something like three terms, there's no way that you can apply the previous method. Okay, so then what is it that which method then should we be using? Yes, so we'll be using this method called the substitution method, where we need to convert the exponential equations to quadratic equations. Alright, so what we're doing is that we're going to replace 2 to the power of x with the letter a, or any other letters, can be b, c, or whatever letters you want to think of, but of course not x, because x has already been used as an exponent as the power base 2. Right, and then you end up getting a quadratic equations, and we will solve it. Right, so we're going to do some examples to see how we can solve this kind of questions using substitution. Right, so let's look at this. Okay, if you look at this one here, we have three terms. Right, so if you have the three terms, then we have to apply this substitution method. Right, so to do that, let's recap on some rules under indices that's important. For example, this one and this. Okay, so why are these two rules important? Because we will need to actually rewrite 2 to the power of 2x as 2 to the power of x times 2 to the power of x, because then that will give us x plus x, right? That will give us 2 to the power of 2x. So why is it that I need to break it up into 2 to the power of x times 2 to the power of x? Because I'm going to substitute 2 to the power of x with the letter a. Right, so you see that we end up getting a quadratic equations where we can factorize it, find the values of a, and because a is a substituted values for 2 to the power of x, right, we are not done just finding a, we need to find the values of x. So therefore we need to substitute back your a to be 2 to the power of x. So the first equation will be 2 to the power of x equals to negative 4/3, which in this case here it's not valid because it's not possible for one side of your equations to be positive and the other one to be negative. There's no such value for x. So therefore the first equation is not applicable. However, the second equation is possible. To the power of x is equals to the power 1. So therefore, x is equals to, oh, I make a mistake here, sorry. X is equals to 1. Alright, so using the same skills that we have learned just now, you may want to try this on your own, right? So I'm going to give you a hint. You may need to simplify a bracket square root 2 cross bracket to power 4x. Convert this. This is the radical form. Convert it into the index form. So square root 2 means 2 to the power half, and then you simplify it, and then you apply exactly the same method as what we have used earlier on, and you should be able to get the answer. Okay, so this is another question. You can try it on your own, right? So for this, right, if you were to recall these rules, right, so basically you just break it up into 3 to the power of x times 3 to the power 1, and then you can just substitute 3 to the power of x to be a letter b or any other letter that define it suitable. Right, so far what we have done is some basics and intermediate questions. So for more challenging questions, you may want to refer to the link that's shown on the screen. Right, so happy learning.